Okay, now we move on to the next subtopic, which is 4.2, the remainder theorem. Okay, in this chapter, you should be able to use the remainder theorems. And okay, first of all, you need to understand the definition of the remainder theorem. Okay, when a polynomial px is divided by a linear factor x minus a, then the remainder is pa. Okay, so the key point is here a linear factor x minus a. Okay, so the remainder will become pa. Okay, meaning that x minus a over here is your divisor. Okay, then you get a remainder pa. Okay, not over here. If px is divided by x plus a equal to, this is also equal to x minus x minus negative a, or then the remainder will be p negative a. Dia ambil yang ni, yang dalam bracket ni. Okay, if px is divided by ax minus b, or also known as, we can also rewrite as like this, ax minus b equal to a bracket x minus b over a close bracket. Then the remainder will be pba. Okay, so dia actually ambil yang ni, belakang ni. Okay, example, find the remainder when px equal to blah 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 is divided by a x plus 3 and b divided by x minus 3. Okay, so for this one, you don't have to perform the long division, okay, for this kind of question, because we're going to use the remainder theorem. Okay, so you have polynomial like this, and you have your divisor or linear divisor x plus 3, so you can rightly choose, or x plus 3 you can write it down as you can write it down as x minus 3, right? So it's going to be the same. X minus 3, it become x plus 3, okay? And for this one, you can write it down back as x plus, I should erase this one. So this one, if you rewrite it, you're going to have x minus positive 3, like that, right? So for the A, the remainder theorem, macam mana kita ambil remainder theorem tu, you ambil yang ni, yang dalam bracket, negative 3. Bila you dah tulis balik ni, dia mesti dalam bentuk x minus. Kenapa x minus? Sebab dia macam ni. Dia punya key point is this one. X minus. Dia tidak tulis x plus. Dia tulis x minus. So, you kena leraikan you punya divisor tu dalam bentuk x minus a. You kena tukar dia dalam bentuk x minus a. So, bila kita dah tukar, dia jadi macam ni lah. X minus 3 untuk dapat benda yang ni kan. So, you ambil yang ni, yang belakang ni. So, the remainder theorem tu, kata kita ambil yang negative 3 ni. So, macam ni lah. So, this negative 3, you substitute dalam this polynomial punya x. So, you have this x to the power of 4 plus x to the power of cube. That x you're going to substitute with negative 3. You substitute everything, every little x over here with negative 3. Then you key in your calculator, then you get the answer is 19. So, your remainder is 19. This is your remainder. Okay? This is your R. Easy, right? So, you don't have to perform the long division to get your, or to obtain your remainder. You just use this remainder theorem. You substitute. First, you have to rewrite this one into this form, x minus a. Then you get the a. You substitute it into the polynomial. Okay. So the same with this x minus 3. We rewrite it in this form, x minus a, or the x minus a. So your a will be 3, right? So this 3 you substitute into this polynomial punya x. So you get the answer is 97. So that's it. That is the remainder theorem. That is the use of remainder theorem. Okay, more example. When you have this kind of polynomial, x to the power of 4 blah 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 is divided by x plus 2. The remainder is 6. Okay, dia dah bagi tahu the r is 6. This is your R. Determine K. Kita nak kena cari this K pula. Okay, but how about this? Dia kata divided by x plus 2. So you need to write it down in the form of x minus a, right? X minus 2. Macam ni. Kan? So kita nak kena tulis dia dalam x minus a. Dalam bentuk x minus a. You have to find your a tu. So your a is negative 2. Okay, so this negative 2, you're going to substitute into the x. You're going to substitute dalam every little x you have over here. So you get the answer is 16. Macam mana I tahu jawapan dia 16? Sebab dia dah bagi tahu dekat sini. The remainder is 16. Remainder dia is 16. But then, you tulislah semula yang ni. Negative 2 plus k times negative 2, you tulis semula, then you add the r equal to 16. Okay. Then yang ni you dah expand, you have to expand this one first, then only you get your k equal to 3. Ini dah bila you dah rearrange, susun semula, then you get your k equal to 3. Okay, more example. The polynomial ax blah 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 left a remainder of negative 8. Okay, dia punya remainder negative 8. So we highlight this one first. When it is divided by x minus 1. Okay, ni dia punya divisor, x minus 1. So this is actually equal to x minus a, kan? And a remainder of 11 over 2 when divided by 2x plus 1. So, kita kena pecahkan juga ni, tulis dalam bentuk x minus a. Determine the values of a and b. So, in these situations, you have 2 remainders and you have 2 divisors. Okay? So, you have to find 2 unknown, a and b. So, what happened is that kita ada polynomial yang ni, yang dia dah bagi ni. This is your polynomial. Kan? Ni adalah you punya polynomial yang ada unknown A, ada unknown B. Okay. So, first dia kata, kalau kita, we have a remainder of negative 8. You have remainder of negative 8 when x equal to negative 1. So, your A equal to 1 lah. From here, you can obtain your P equal to 1. So, ini adalah you punya A. Kan? So, P1, you akan dapat negative 8. Negative 8 ni just now, dia punya remainder. Okay, so you substitute lah this one into this equation. So, you get 1 times A, negative 5 times 1 to the power of cube. Mengganti masuk dalam semua x over here. So, it's equal to negative 8. And then, you susun, rearrange, solve for this one. You obtain first equation. This is your first equation, okay? Also, we have second, we're going to obtain second equation from the one, dia bagi yang 11 over 2 when divided by 2x plus 1. So, what happened is that from here you tahu you punya you mesti susun dia dalam bentuk x minus a. So this one, it become x minus 1 over 2 lah kan. So dia become x minus 1 over 2. Okay. X minus lagi. Okay. So you dapatlah this one. Dan dia punya remainder adalah 11 over 2. Yang ni. Okay, so I just substitute this one. Substitute this a into every little x over here. Then you get the remainder is 11 over 2. So you have obtained the second equation, which is this one. So when you have two equations, what you're going to do next is perform the simultaneous equation, persamaan serentak. Either 1 tolak 2 ataupun 2 tolak 1. So in this case, minus 2 minus 1. 2 minus 1. So I obtain b equal to 1 and a equal to 2. Okay. So the solution is quite long, but as long as you can understand how to perform how to use the remainder theorem, the trick is there. You just need to rearrange this. You identify the remainder, and then you just need to rewrite the what we call it, divisor. Okay, in this form, x minus a. Because you want to obtain this a. This a that you're going to substitute into this. Okay, more example. Determine the remainder when ini we need to find the remainder pula. Selalunya remainder diberi. Determine the remainder when px equal to this one is divided by x square minus 1. Okay, so dia bagi dalam x square minus 1. So from x square minus 1, you pecahkan. X square minus 1, dia adalah quadratic. Bila you factorize dia, you get x square minus 1. When you factorize, you get x minus 1, x plus 1. Okay, see, we have two divisor over there. Since the divisor is a quadratic, x square minus 1, then the remainder is a linear. Kalau dia quadratic, maksudnya you punya remainder akan jadi linear, ax plus b. Dia kurang satu lah. Dia ada sebut sini x square, di sini akan ada sebutan x. X plus b. Okay, so kita dah tahu bentuk remainder kita dalam bentuk macam ni. But then, first we need to substitute. Sekarang kita ada ni kan? 1, negatif 1, 1, 1. So you substitute this 1, negative 1 and 1 into ni, ke dalam ini. So you obtain first equation. Second equation, you're going to obtain by substituting negative 1 into the polynomial. Sama juga. Okay, you obtain second equation. So when you have two equations, you perform simultaneous equation, persamaan serentak, you obtain a minus 6, a equal to 6 and b equal to 9. So, kita dah ada a and b dan kita tahu kita punya remainder dalam bentuk yang ini, ax plus b. So, kita ganti masuklah. Tadi kita kata kita punya remainder dalam bentuk ax plus b. Okay. So, your a is 6, your b is 9. Okay, more example. When polynomial, this one is divided by x square minus 1, the remainder is 2x plus 3. So this is the remainder. Find the values of p and q. So now you need to find p and q pula. So, macam kita tahu sebelum ni, px, the polynomial, can be written down as this one, qx times dx plus rx. So this is the polynomial you have. We're going to write it down using this form, qx, which is the qx we still don't know. So we let it as qx. Dx, divisor dia kita tahu. Divisor dia is this one. This is the divisor. This is d. Dx plus rx. And the rx already given over here. This is the rx, right? This is your r. So this is your r. Okay, substituting x equal to 1. Substituting x equal to 1. Okay, why did I substitute 1? Macam mana I dapat 1 ni over here? Because of this. X square minus 1. Divisor dia, kita tahu kalau yang ini, kita boleh dapat 1x minus 1. 1 lagi x plus 1, right? So kita ganti masuklah 1, 1, 1, negative 1. The other one is positive 1 into this equation. So into this equation, sorry, yang panjang ni. So you dapatlah p plus q equal to negative 5. So you obtain first equation. Then you second one, you substitute pula x equal to negative 1 into this equation. This is your px. Ini you punya px ya. So you obtain the second equation. So sama jugalah, asal ada dua equation, you have to perform simultaneous equation. So you obtain the p and you obtain the q. Okay. So that's it about remainder theorem. I think remainder theorem is much more easier than the long division just now, kan? In the first subtopic.